Welcome to The Explainer. All right, if you're a developer, you know this pain. You build a web scraper, it works beautifully for a day, and then bam, you hit a wall of CAPTCHAs. It is an absolutely endless, frustrating game. But what if I told you we've been fighting this war on completely the wrong battlefield?
This one idea right here is going to totally reframe how you think about getting data. You see, it's not about building a bigger, better battering ram to smash down the front door. It's about finding the side door that's already been left unlocked. So let's first dig into why that front door, the browser, is so heavily guarded in the first place.
We have all been there. One minute your scraper is humming along, the next it's dead in the water staring at access denied. It feels totally random, like an impossible game. But here's the thing, the server knows your bot before you even send your first request.
Yeah, for years, the old advice was just rotate your IPs, fake your user agent, and you'll be fine. But that's like changing your license plate after you've already been pulled over. The real detection is happening way earlier, down at the network level. It's not about what you ask for, but how you say hello.
So before your code even gets a chance to ask for the web page, its cover is blown. That very first packet it sends, the client hello, is basically a list of its technical capabilities. You know, what kind of encryption it can handle. Well, the specific combination and order of those options creates a unique digital fingerprint.
And this right here is the smoking gun. Your scraper is shouting, "Hey, I'm Chrome on Windows," but its TLS handshake is screaming, "I'm a Python script using OpenSSL." A real Chrome browser uses a totally different crypto library, which gives it a completely different fingerprint. A server sees that mismatch in a nanosecond, and that's it. Connection dropped.
And trust me, it goes way beyond just that initial handshake. It's a whole gauntlet of checks. Anti-bot systems are looking at everything: your graphics card, the fonts on your system, even your screen resolution. Trying to fake every single one of these things perfectly, it's a path to insanity. It is a losing battle.
Okay, so trying to fight this fight in the browser, it's a dead end. But what if we just stop? What if we stop trying to break down the front door and just walk around to the wide open service entrance? Well, that entrance is the API that serves the official mobile app. And just look at the two worlds here. On one side, you have web front ends. They're built for us, for humans. They're messy, complicated. But on the other side, you've got mobile backends. They are all about speed and efficiency. They speak in clean, structured JSON, data that's already perfectly formatted for a machine. You could almost say they're designed to be scraped.
So this is our master key, the man-in-the-middle approach. We're not going to try to impersonate the app. No, we're just going to put ourselves right in between the real app and the server so we can eavesdrop on their conversation. By doing this, we get to see the exact trusted requests the app is making and the beautiful data it gets back.
So here's how it works. We're essentially setting up our own little listening post. The real mobile app sends a request, our proxy snags it, sends it along to the server, and then on the way back, it captures that perfect, clean JSON response. We're not fighting fingerprinting at all. We're just stepping around it completely.
So how do you actually do this? I know it might sound super complicated, but the toolkit for listening in is surprisingly simple. The whole goal is just to watch the app in action, learn the language it speaks, and then speak that language ourselves. Here's the playbook.
Honestly, this is all you need. Step 1, you fire up a virtual Android phone right on your computer. Easy. Step 2, you tell that virtual phone to send all of its internet traffic through your local machine. Step 3, and this is the absolute key, you install a special security certificate. That gives your proxy permission to decrypt all the secure traffic. And finally, step 4, you launch a tool like Mitten Proxy and just watch the magic happen as the clean API calls and JSON data flow right onto your screen. And boom, this is the payoff. This is what it's all about. Look at that. No messy HTML to parse. No CSS selectors that are going to break next week when the website gets an update. Just the pure, structured data you wanted from the very beginning, ready to be dropped right into your application.
Now, this whole mobile backdoor thing works because of a simple trade-off. Mobile apps need to be fast and reliable, so they can't afford the heavy-duty security we see on the web. But you know how this goes. In the security arms race, no advantage lasts forever, and a new defense is already coming.
The next big hurdle is a technology that's designed to make stealing session cookies completely and utterly useless. It's called Device-Bound Session Credentials, or DBSC. And it's a real game changer because it ties your login session directly to your physical hardware. So here's how it works. When you log in, your phone creates a unique private key that's locked inside a secure chip.
Think of it like a physical key that literally cannot be copied or removed from your device. The server then locks your session to that specific key. So even if a scraper manages to steal your session cookie, it's completely useless without the physical key to unlock it.
You can really see the escalation on this timeline. The past was all about simple tricks, faking user agents. The present, like we've been talking about, is about intercepting these mobile APIs. But the future? The future is going to be a battle over hardware itself, with tech like DSBC and hardware attestation leading the charge.
And this is the question that every developer in this space really needs to be thinking about. The game never ends, the battlefield just shifts. As our hardware becomes the new lock, what's going to be the next key? The need for data isn't going anywhere, so innovation will always find a path. The only question is, what will that path look like?